Okay, hi everyone. This is the first demo recording for the Vortex based math laboratory. My name's Ruben Neal. I've been investigating and researching VBM since about 2007, 2008, something like that. And I'm also the admin on the VBM369 discussion forum. Sorry about the quality of the recording. That's why I've been trying to hold off until I get better recording equipment, but for the time being I'll just do this and maybe do some better quality, proper kind of official versions later on based on just some of these rough recordings. I'm just using AutoCAD. This is all I use, but I don't know how to use anything all that complicated. Just basically the circles and straight lines and polygons, and then I can find ratios between sizes and lengths of things, stuff like that. That's all I really need, basic sacred geometry type of principles. Okay, some of the things I'm going to show are just the different ways of presenting the modular systems that I can do, at least in 2 dimensions, and all the different unique characteristics of each modular system, the geometry associated with each modular system, and also its Fibonacci series equivalent. Okay, so here's the 3 main parts that you really need to know about. All you do is you put your modular system around a circle. So I'm using mod 3, which is 3 times 3, which is 9. And just to make it simple, we'll just do 1, 2, 3, 4, 5, 6, 7, 8, 9. This isn't the only way you can do it, but makes it simple. This is a polarized section, where this section here is all you actually need. 9 numbers, modular 9, except there's a mirror number for each of these, and a positive and negative value. So when you dimensionalize this modular system, it needs to be polarized. All the numbers up till the last highest number in the mod, as 9 is here, is polarized. So there's a polarity 1 and 8, there's a polarity 2 and 7, there's a polarity 3 and 6, there's a polarity 4 and 5. There's no polarity for 9 because 9 is a monopole, or its own mirror, which is to say it's the center and has no other point that it occupies. It occupies the same space, whereas these are stereoscopically projected. 3 and 6 is the stereoscopic projection of the 9. And then these other numbers, which are in a different circuit, are dimensional coordinates. These aren't actually, nothing on the surface of the torus really reaches these points, because they're just they're the things that are creating the shape. But any particle, so to speak, or anything traveling on the torus is only going to be interacting with the 1, 2, 4, 8, 7, 5 coordinates. 3 and the 6 is simply the furthest possible points, which is to say the poles, and also define the direction of spin and so these are a polarized direction of spin, which would basically represent the torus in itself, but then they also have a polar aspect to them as well. So there's lots of different ways you could interpret this into dimensional coordinates. Well, not lots, but there are a few different possibilities depending on which scale you want to take it to and whatnot. But what's really interesting is that once you start looking at these other mod systems, which are primes squared, so first prime being used being 3, not 2, and then 5 squared is 25, and 7 squared is 49. This isn't a prime, but you'll find out that even though it does behave in much the same way as the others, it also borrows characteristics from mod 9, which is to say also that it's since 81 can be divided by 9 or 3, it's not prime because its geometry is being repeated. But I wouldn't just throw it out and say it's not prime. It's just a kind of it's just got resonance with other mod systems, so it can be exempt in some cases, except it's still relevant to do, and you'll find unique characteristics within this that cross-resonate with this one, which is interesting. So, but the prime numbers are all new circuitry and all new geometry that is unique and will never be repeated. Well, when it is, like this, when it is repeated. Yeah, anyway, so it's basically odd numbers squared, but the primes, just like primes are when you're just counting through regular primes, have unique geometry associated with them. So nothing will do what mod 25 does, but it will be mimicked later on by other numbers divisible by 25. So there's some of the basic maps. You could call them maps, you could call them skins, you could call them matrix squares, you could call them gradient tiling, surface topology, because this will become a 3D or even 4D object, which is to say a 3D object but with spin or motions associated with it. Even though it's really static, but it describes motions depending on what information you're trying to obtain or put. So if you look at a specific pattern over the torus, that's representing a specific motion or vibration. The torus is really fractal and infinite, so it just goes on and on and on. This is just the smallest pieces needed to describe it, which is also why mod 9 of the first prime squared, the first true prime squared, 3 not 2, because some various reasons, is still unique to all else from then on. It's the same way the tetrahedron or the triangle is unique, because it's the most foundational building block, so to speak, the simplest, most direct to the source vibration of the monopole singularity of the 1, which would be really the first mod, but it's just 1. The 1 squared would be the first trip, but it's just a singularity. So this is the spill out, or the projection out of that singularity into more and more complexity, and has geometric qualities. And when numbers are treated geometrically, this is what I'm showing basically. These circuits all have a geometric, a direct geometric equivalent, rather than just that you can associate these numbers or whatever with geometries in all kinds of ways, but this is actually axiomatically describing geometry as numbers. So as you create these geometry around a circle, so you just start with a circle with a triangle, number 3, geometrically. This is the first circuit. In other words, the mod 9 is the first modular arrangement that can be tiled, and it creates just one circuit, the 1, 2, 4, 8, 7, 5 here. So it has a control circuit, so to speak. This is the shape, the general shape of the torus. Roughly speaking, it gets more complicated. And this is a pathway possible over the surface. Well, not necessarily over the surface, but just defining the boundary conditioning of that specific scale of torus. This will eventually turn into a torus. Here you can see 25, modular 25, and modular 49. I'm just using multiples of 1 around the circumference, just as we normally do with the modular 9, even though you could use any multiple arrangement. So this could be multiples of 2, or not modulars of 3, anything that's divides into your control number is your magnetic field counterpart, which is a completely different circuitry. So you exempt multiples of 3 and 6 or 9, because you just have 3, 6, 3, 6, 3, 6, 9, 3, 6, 9, 3, 6, 9, 9, 9, 9, 9, 9, 9. So same with this 25, 5 or 10 or 15 or 20. They're all in vibratory resonance with the control mod. So this is a whole different circuit. So you can have multiples of 1, 2, 4, 8, 7 or 5. But multiples of 8 are just a mirror of multiples of 1, and multiples of 7 are just a mirror of them, just as they are across here. It's the same thing here. If you do multiples and then reduce in modular 25, it's the same thing. So you've got all these numbers that go across here that add to 25 could be considered polar number pairs. So now you have 2 polar controls. So the first one, you've got 1 pair of polar controls with a singularity. So here you still got 1 singularity, but you have 4, or you have a dual version of this stereo. So now you have 2 lots of stereo, and along with it comes 2 circuits, this circuit and this circuit. So instead of 1 circuit, there's 2 circuits. Now if you look over here, see how if you've just got a triangle and a circle, you've just got this one way around. There's no other possibilities between these 3 points. There, you go there, there. There's nothing else you can do. But with 5 points, you can do a pentagon, or you can do every second one and do a pentagram. So you can have two different possibilities of geometry with 5 points around a circle. And also, remember, the circle basically represents the singularity spread out or dimensionalized. So this is really a point that's spread out into a circle. It's really a sphere and dimensionalized with nodal points as to represent specific space-time coordinates or vibrational qualities. I mean, that's a bit interpretive, but it's a bit of context for what's really happening here. Say modular 49, you've got another one. So it's just added. It's gone from one possible circuit to two possible circuits. Here's the actual straight circuits. So there's just one circuit possibility, two circuit possibilities. Now there's three circuit possibilities here: red, blue, and green. And as you do with 7 points around a circle, now you have the heptagon, and then you have this other kind going every 2, then you have this other kind going every 3. And these all create unique ratios unto themselves and also to each other, which gets really interesting also. But for now I'm just showing that how these other modular systems work and what it adds to the original, which is most people really only follow the modular 9 system, and for good reason, because as you get into these other modular systems they get extremely complicated. So here you can see how I was saying there's one possible circuit here. There is one possible circuit, there's a 1, 2, 4, 8, 7, 5, but it's polarized because I've got a polarized skin going here, so I've got one circuit that's polarized. Here you've got two circuits that are polarized. So really, I've got 6 dimensional numbers in this mod system. I've got the 1, 2, 4, 8, 7, 5, 6, which is the smallest amount of points needed to describe space-time, right? X, Y, Z, plus and minus for the 6 directions. I'm still not completely sure how to dimensionalize all this yet, all these other mod systems, but now you have 10. So where you had 6, you now have 10. And where it was sort of like 3 and 3, it's 5 and 5. And so also every number that's divided that's different by 3, so if you just add 3 or you add 6, is the family number groups. So 1, 4, and 7. You can see it with this triangle here. 1, 4, and 7. Because they add 3 and go to 4, and you can add 3 to 4 and go to 7, add 3 to 7 and go back to 10, which is 1. That's called a family number group. But in modular 25, it's you've got 5 numbers per family number group. So I've never done this before, but it'd be 1, and then you'd add 5, go to 6, and you'd add 5 and go to 11, and you'd add 5 and you'd go to 16, and you'd add 5, you'd go to 21, you'd add 5 and you'd go to 26, 26 is 1, so back to 1, Yeah, it's interesting. It makes like a trapezoid sort of shape. Jumps one, crosses, jumps one again, crosses. So that'll be a family number group, those 5 numbers. And there'd be 5 of those, just as there's 3 family number groups that are made up of 3 numbers, 3 threes. Here there's 5 fives. So this is really family number group triangles, and this is family number group pentagons. And then this would be heptagons. Just as defining just representative of the defining axis, really. This middle circuit can be thought of as an axis that is like a linear branch for non-linear non-linear vortexes, basically, around a linear emanation. I don't want to get too complicated there. So if you make these into giant skins, this sort of thing. So I've just made massive tile links on these. This is mod 9. And then I've got overlays of the next fractal iteration up. This is where it gets a bit more complicated. You can move these over the surface, align the middle with the 9, and now these numbers give me a new orientation, which also has a new multiplication series around my compass, new orientation, which is also to say a new sort of layer outwards or inwards, I guess, of the torus. Could mean that, or it could be just another perspective, another orientation. So if you're just changing a perspective on these, because these are actually 3-dimensional, possibly rhombic dodecahedrons. That's really complicated. But anyway, you can see how the original scale here, 1, 2, 4, 8, 7, 5, look at it like that, or you can look at it 1, 2, 4, 8, 7, 5 that way. But it makes these little circuits that cross and define a boundary condition. If you add all these numbers together, they'll always equal the middle number in that mod. So when reduced to mod 9, obviously, always reduce them to mod 9 while using mod 9. And so you can see that this one that was up top here is now just moved down to this position. And you can see how the 2 that was there is now just moved down into this position. They've also polarized, so what was a -2, because the polarized part of it doesn't change. So that's positive and a negative. So the negative is still in the middle, positive still up there. But these numbers are moving around, so to speak. So the next iteration, that 1, will move down here. If you reduce the numbers of the Fibonacci sequence by the modular system, either mod 9 mod 25, mod 49, you will get unique strings of numbers that will contain these same circuits. So okay, here's the mod 25 skin, for example. So this is just the skin you make up out of the regular principles of vortex-based mathematics, just as you did with the mod 9. And this is the polarized skin. And this is actually the first fractal expansion on that skin. So if I continue to lay out this skin, and then instead of taking one number like that, I went out and did the next scale, and sorry, the next scale after this, since this is 5 by 5, will be 7 by 7, and so you lay out 7 by 7 arrangements of this same kind of grid over this initial grid, and you get a new arrangement of numbers, which is this. Just to go over this quickly, so I call it the first fractal expansion, which is just a reorientation of this same initial skin. I can start from any orientation, but I've started with multiples of 1 and 24 going up and down, just as the usual mod 9 skin you'd normally see is the same. You'd have multiplications of 1 and 8 up and down ways. So this is the next orientation. It gets complicated, but that's what it looks like. What I found was that I took the Fibonacci sequence. Here it is. You can see it starting 1, 1, 2, 3, 5, 8. But you can't have a number bigger than 25 if you're using mod 25. So once you get to anything bigger than 25, so this is 34 minus 25, which is 9. So that's mod 25. So all I'm doing is making the Fibonacci sequence, but I'm putting it in mod 25, and I end up with a certain amount of numbers until it just repeats. So the next number here will just be this. So this whole thing will just repeat after this many numbers. Happens to be 100, exactly 100 numbers. So if anyone's familiar with the mod 9 Fibonacci, it's modular 24, so it repeats after 24 positions, whereas this repeats after 100 positions. And you end up with these new circuits. So if I just line up where the 25s and the 5s and 15s and the 20s, the 10s are, that's pretty much all you need to know where the orientation of is to get all these other circuits to come out. You just line up these ones. So this was just a long string going down like these, and then I've just broken them up so as to read out these circuits. So I just folded it up 10 by 10 in this case, and I've got all the circuits of the original skin here. So look, here's 5, 10, 25, 15, here's 5, 10, 25, 15, and then 20, 20, 15, 20, 20, 15, so on. So that circuit is right there. Now this circuit 2, 8, 7, 3, 12. Look over here, 2, 8, 7, 3, 12. So that's this row. I know this is crude, but just got lines connecting from that circuit to this circuit is the same circuit, except that these I'm just getting out of modulo 25 is just my modulo 25 skin. But this is the Fibonacci sequence in mod 25. Should really have nothing to do with it. I didn't do anything to do with Fibonacci to create this. This is just how you tile modulo 25 so that you've got polar pairs all the way across 25 in any direction. So any of these numbers that are in opposite positions to each other across the center, 13 and 12 makes 25, 19 and 6 makes 25, 1 and 24 makes 25, 9 and 16, 10 and 15 makes 25, 11 and 14 makes 25. Anything symmetrically across the major axis will equal 25. And that's really how you just make the skin. But that creates these circuits, which are really unique and interesting, and they show up right here in the Fibonacci sequence exactly. So here's was 1, 14, 21, 19, 1, 14, 21, 19, and there should be 16, 24, 11, 16, 24, 11. So that's that circuit, that's that one, that's that one. All these circuits are in here, but see that every second one is this original skin. So that one, and then the second 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 one. All the original mod skin. And then I had these other circuits, and I was wondering what do they belong to, because you've got all of the circuits of the original skin accounted for already. But I'd luckily already been dabbling in the fractal expansions on top of the original mod 25 skin, and this was the first fractal expansion. And I realized that these circuits, every other second one that's not in this one is in this one. So there's 25, 5, 15, here's 25, 5, 15, 25, 5, 15, 15, 20, 15, 5, it's all there. The next one, 1, 19, 11, 1, 19, 11, 9, 21, 24, 9, 21, 24. Where's the next circuit? 3, 2, 18, 12, 3, 2, 18, 12. There's that circuit. Every circuit is accounted for perfectly. No redundancies, no omissions. Every one of these circuits that's in the original modulo 25 polarized skin, and it's the first next fractal expansion when you use 7 by 7, the next one out, and create a new skin on that new fractal expansion. And each square will all add to that central number still, so you can add all the numbers that are in any square you take, and it'll equal the center. As long as it's an odd amount, then you get a central tile. So that is just undeniable. That's straight mathematics. And it incorporates not just all of the exact original skin, but a fractal expansion, or the next orientation, interlaced within it.